All right, this is Mr. McMurray, and we are here for Lever Lab Part 2, okay? And so we're going to be looking at this worksheet. We're going to be working at the bottom again, bottom page here. Notice it says first class lever, and then there's a row beside it, and then two more rows. You will need all three rows, so start on the one right up beside where it says first class lever. Okay, then we'll go down to second class and third class. But let's do first class first. First things first. All right, so here we go. According to this one, we are putting a weight on 40 centimeters to the right of our thing here, okay? And it is a 10 Newton, or 10.0 Newton. So, on your paper where it says resistance force, that's the resistance, what we're trying to lift, it is 10.0 newtons, okay? Now, what we're going to do is we're going to lift that with a spring scale, and we're going to see how much force does it take to lift it with the spring scale. This one is only 30 centimeters, okay? So your two distances, where it says resistance arm, that's going to be 0.40 meters, that's 40 centimeters, 0.40 meters, and for the effort arm, from here to here, is 30 centimeters, or 0.30 meters. Okay, so that goes that. All we got to do is find the effort force now. And if I pull on this, and I want to make sure I read it on the Newton side, and it's going to be right at 13.7. Okay, so we're going to say for the effort force, we're going to say 13 let's make it 8. Okay, so 13.8 newtons. That goes in the effort force. Okay, so we should have 4 boxes all filled in there. And the only thing you'll have to do is calculate the actual mechanical advantage, which is just the resistance force divided by the effort force. The newtons will cancel, so you'll not have any units, just a number. Okay, just for the record, this one should be less than 1. All right, then for the ideal mechanical advantage, it would be the effort arm divided by the resistance arm, which also should be less than 1. Okay, all right, so that's the first one. Now, the next one, we are going to scoot this and make the resistance arm less. Okay, so instead of 40, we're only going to put it at 20, which is going to be about 69.6. Let me get that on here. All right, right about there. Okay. All right, now we're going to lift it. Notice this time, before the resistance arm was bigger than the effort arm. Now the effort arm is longer than the resistance arm. Let's see how that, made a difference. Sorry, I got the hiccups all of a sudden. All right, here we go. And we pull down. Now it only takes 5, 6, 7. All right, 7.0 newtons. Okay, so almost half as much force. Okay, 7.0 newtons. Basically, we're going to find the longer the effort arm is compared to the resistance arm, that's going to make it easier and take less. All right. Now, we're going to do one more, and that will be with this one's going to make the effort arm even longer and leave the resistance arm where it is. Okay, and so we're going to subtract 45 from that, which is going to make it 4.6. So it's going to make it pretty long. All right. And now we're going to pull on that, and it's going to bring it down to, say, 4.5 newtons. Okay? 4.5 newtons. Okay? Sorry, I got a little carried away there. Okay. So for the second first-class lever that we did, the resistance force is still 10 newtons. All three of them are 10 newtons for the resistance force. You can put the same thing for each one. The resistance torque on the resistance arm on the second one should have been 20, and the resistance arm on the third one should be 20. The effort arm was 30 on the first one. It should be 30 on the second one, and it is 45 centimeters on the last one. Now, I say that it should be 0.30 meters, 0.30 meters, 0.45 meters, okay? The resistance should be 0.40, 0.20, 0.20, because we're changing it from centimeters into meters, okay? And then I told you what the effort forces would be, and then you should be able to calculate the rest. All right, let me take a short pause and we'll get ready for a second class lever because everybody's excited about that. All right, and here we are again, just as we promised. So now we've got a second class lever. We have the fulcrum, which is down here at 5 centimeters. And we have this one, which is 65 centimeters away from it. That's where our weight is. So our resistance force is still 10.0 newtons. There we go. And the distance is 65 centimeters, so that would be 0.65 meters. So you need to write that down. All right. So the resistance arm is 0.65 meters. The resistance force is 10 newtons. Okay. Now the effort arm is 85. Okay, so that's going to be 0.85 meters. Okay. Now we need to find how much effort is it going to take to lift it, because now we're going to be lifting it up. Okay. So we're going to lift it up, and we're going to find that it takes about 8.3. Okay. Or excuse me, let me see it again. No, make that 9.3. Okay, so it's about 9.3. So we're going to write that down, 9.3 newtons, and that is the effort force for that one. All right. Now, this is like a wheelbarrow. This would be like the wheel. This would be the weight you're lifting up, and this would be the handles. In this case, the weight is right back toward the handles. All right, but now we're going to scoot it up a little bit so that it's only 45 centimeters from it, or 0.45 meters. So now the resistance arm is, so for your second one under this second one, on the second class lever, it's going to be 0.45 meters, the resistance arm. Of course, the resistance force is still 10 newtons, all right? The effort force, on the other hand, though, now, when we lift it up, is only 5.8, okay? So we're going to say about 5.8. All right, 5.8 newtons. All right, so as you can see, once again, the effort arm is staying long, but we're making the resistance arm shorter, so by comparison, it is more the same. All right, guess what? If we scooted it even closer, it would be even less, only about 3.5 or so. Okay, so basically the longer the effort arm is compared to the resistance arm, it's going to get easier and easier to do it. And in this type of pulley, since the effort is on the end and resistance is in the middle, the resistance arm is always going to be less, and hopefully your mechanical advantage is always greater than 1. All right. So if you calculate your actual mechanical advantage and ideal mechanical advantages, hopefully you'll get that done. All right, give me another second, and we will be back with the third and final type of... All right, this is Mr. McMurray, and we're on for our last lever, which is going to be the third class lever. This one's a little tricky. All right, we have our fulcrum here. We're going to pull up on our weight right here, and we're going to lift our 10 Newton weight over there. Okay, this one's a little hard because I got to hold this down and pull that up at the same time, but we will get it done. All right, now, just for the record, your resistance force is still 10 newtons, 10.0 newtons. Your resistance arm is going to be 70 centimeters or 0.70 meters, and your effort arm is going to be 0.30 meters or 30 centimeters. Okay, so it's going to be short. The resistance is going to be a lot higher. So let's see how many newtons this will take if I lift it. All right, we're going to say about 16.5. Okay, so for a 10 Newton weight, it actually takes 16.5 to lift it up, which is a lot more, and so almost 50% more, over 50% more. So that doesn't seem very useful, does it? But you will notice that when I pick this one up a small distance, the weight over here actually goes up a farther distance. Okay, so this may only move an inch, that might move 2 or 3 inches. So it is multiplying our distance, which is why you would use one of these type of things. All right, now we're going to move them we're going to move this one up 10. All right. So it's going to be up to here. All right. And we're going to move this one back to 90. That's going to be a bunch. We're going to scoot a little farther that way, or we're not going to have room. Okay, so we're going to scoot that one to 90. From there. All right. Well, that's going to be very difficult. We'll see if Mr. McMurray can do it without hurting himself and anybody else involved. All right. So here we go. Now, so once again, 10 newtons. For the second one on the third class lever, now our resistance arm is 90 centimeters or 0.90 meters. And for our effort arm is going to be about 30 centimeters or 0.30 meters. Okay, so let me get this ready, see if I can lift it, and measure it all at the same time. Okay, we'll hold this here. We'll lift it up. And that is not going to fit on that scale. All right, so we've got to go get a different one. All right, so let's try this one again. All right, here we go. And we're off. And it's going to be about 30. Let's see. Whoa. All right. All right, it's about 30 up there. We're going to say 33, okay? 33 newtons. So over 3 times as hard, okay? That's going to be 33.0 newtons, okay? That's a lot harder, but that's why we don't use third class lever to do heavy objects. Usually it's fairly light stuff like brooms and stuff like that that don't require a lot of force anyhow. All right? Okay, so now that you have that data, you should be able to fill out the actual mechanical advantage, the ideal mechanical advantage, and then you may should be able to answer the questions with the rest of the lab. All right. So hopefully that works out good. If you have any questions, you know how to let me know, and just email me or send me some kind of notification through Canvas, and we will help you with it. All right. Hope you have a great Friday and a great weekend.